Oh.
When's the chem quiz?
The heat and phase change quiz, it's tomorrow.
Do you understand this?
I don't get any of this.
I mean, it kind of makes sense if you look at the video.
Let's see it.
Do you have a test on heat and phase changes? And listen up, because this is for you! Let's take a look at the 6 different phase changes by their logical groupings. One important aspect of phase changes to remember is that we are dealing with potential or stored energy rather than kinetic energy, which occurs with a change in temperature. It's very important to note that temperature is never affected in any of these phase changes.
Let's start off with freezing and melting. Here we have some liquid lemonade, which we will pour into these popsicle molds. When we put this in the freezer, freezing will occur. In the freezer, our lemonade is going to begin to lose heat. As the temperature drops, the average kinetic energy of the molecules will decrease and the molecules become more ordered as a solid. The lemonade lost its heat, making this reaction exothermic. The freezing turned the lemonade into a solid popsicle. Now let's take a look at the change from a solid to a liquid, otherwise known as the melting process. Let's use ice cream as our example.
As the ice cream comes out of the freezer, it begins to absorb its surrounding heat. The ice cream molecules begin to vibrate in place, and then they collide with each other more rapidly as it begins to change its state. The individual molecules begin to break apart, which makes the solid change to a liquid state. The ice cream took in energy when absorbed the surrounding heat, classifying this phase as an endothermic reaction. Let's take a look at the phase change diagram for this process. As the temperature increases when the ice cream is out of the freezer, our line goes up. However, phase changes don't occur during this temperature change. They occur here with our plateau line.
Vaporization and condensation are another pair of phase changes. I bet you didn't know that when you boil water to make pasta, vaporization is occurring. Check this out. When we begin, our water is at room temperature. As we turn on the stove, we're adding heat. Therefore, this is an endothermic reaction. At this time, the water is gaining heat, but the phase change has not yet occurred. As soon as the water has reached 100 degrees Celsius, it has started to vaporize to gas. In this vaporization process, the attractive forces between the liquid are overcome and the liquid turns to a gas, as you can see rising from the pot. If we add pasta to this boiling water, it will cook rather quickly.
Now for condensation, or the change of a gas to a liquid, let's look at this demonstration using a shower as our example. The hot water is producing steam, which is accumulating on the sides of the shower and making the phase change from a gas to a liquid. We are demonstrating an exothermic reaction, for the gas is losing heat while changing to a liquid. This is because a gaseous molecular structure is less ordered than a liquid's, so when it makes the phase change from a gas to a liquid, it loses heat as it moves to a more ordered structure.
Sublimation is when a solid goes to a gas without going through the liquid phase. An example of this is dry ice as shown in this picture, where a solid turns into a gaseous form. This process gains heat as a structured solid goes to a less ordered gas.
Now for deposition, let's look at some snowflakes. First of all, deposition is an exothermic reaction, where the gas molecules lose heat in order to form into solid structures. Water droplets latch onto dust particles in the sky and create solid ice crystals. When the ice crystal falls to the ground, the water vapor forms into a primary crystal that forms the 6 arms of the snowflake. The water vapor, or gas structure, becomes more ordered as its particles become solid and begin to limit their movement.
Believe it or not, even though these phase changes are all around us, there's still some math involved in these changes. Your change in heat equation is only for a change in temperature, not a phase change. So if you have a substance like water whose temperature but not its phase is changing, this is the formula to use. We're going to use this formula for calculating a change in heat. So if you're given 3 of the 4 values, you can calculate the missing value. The specific heat capacity can be found on your green table, depending on which substance you're dealing with. But make sure you memorize that the specific heat capacity of water is 4.184 joules over grams times degrees Celsius. Let's try our problem. Our mass is 125 degrees, our specific heat is 4.184, and our change in temperature is a positive 57 degrees Celsius. So when we multiply this out, we get our change in heat, which shows us that this is an endothermic reaction.
There are two values that we need to be concerned about when dealing with these types of problems: heat of fusion and heat of vaporization. Heat of fusion is used with melting and freezing problems. The value that you need to remember is 79.8 calories per gram. For heat of vaporization, used with boiling and condensing problems, remember the value 540.2 calories per gram. Now for formulas, remember these are used with a change in state, not in temperature. The actual formula is simple. The change in heat equals the mass of the substance multiplied by its heat of fusion or heat of vaporization value. You can solve any variable in these equations by isolating it and plugging in the given values in the problem. Let's look at an example. Let's say your problem is what mass of water at 100 degrees Celsius can be completely boiled using 8,250 joules. By plugging in these values, you can isolate the variable, and you find that the mass is 3.650 grams. Now you know all you need to know about heat and phase changes.
Good luck on that chem test.
Oh!